Here at Agrivert, we specialise in cost-effective and sustainable organic waste management solutions. Over 20 years, we've developed a leading position in the UK organics treatment market. We operate in a unique portion of this market, simultaneously designing and constructing complex facilities for others, whilst building and operating our own food waste, green waste and sewage sludge recycling facilities. Our AD facilities produce enough green electricity to power 25,000 local homes and businesses each year. And since we started operating, we've fertilised over 360,000 hectares of UK agricultural land with our nutrient-rich biofertilisers. Today, Agrivert works with over 30 local authorities and water companies in the UK, providing unrivalled food and green waste and sludge recycling solutions to both them and numerous waste collection businesses across the country. This short story will concentrate on our sewage sludge processing capability. We will explain the journey that Agrivert takes to treat and reduce the volume of indigenous sewage sludges and cake, converting them into renewable energy and rich biofertilisers. Agrivert is the market leader in sewage sludge processing. We design, build, finance and operate treatment facilities, providing a wide range of services using our expert in-house design team. Our sludge processing facilities are located on the same site as a Sewage Sludge Treatment Centre, or STC, therefore receiving indigenous primary and secondary sludges directly from that treatment works. Untreated primary or secondary sludges can also be dewatered at smaller satellite sewage treatment works. These would be dotted around the locality of the main sewage treatment centre. Using our storage systems at these sites, dewatered cake can be stored without odour before being loaded onto vehicles for onward transport to our main processing facility. This completely automated and sealed system means there is no need for manual intervention and therefore no requirement for mobile plant or labour. Using this method, we can achieve payloads of 28.5 tonnes at a time, which significantly reduces transport costs. We find that developing a hub of smaller satellite works around the area is a very cost-effective method of treating a larger volume of materials from a wider conurbation. When importing sludges from the main treatment works, we receive material with an average dry solids level of 2 to 6%. To allow for efficient downstream processing, this solids level needs to be increased to 25%. To achieve this, the material is dosed with polymer to encourage flocculation, prior to being run through a series of screens and a centrifuge to dewater the material. Our dewatered sludge is now stored in a silo ready for blending with pre-dewatered cake that we receive from external satellite treatment works. This cake is delivered in bulk loads of up to 28.5 tonnes at a time. It's rapidly discharged into a sealed bunker within our specially designed odour-controlled building. Fast-action roller shutter doors operate automatically, keeping odour escape to a minimum whilst ensuring no need for any manual intervention or mobile plant. Sludge is conveyed from the bunker via sealed screw conveyors into our storage silos. All internal components are extremely robust and slow-moving, therefore low-wearing and reliable. A complex system of moving floors, screw conveyors and pumping systems meter the cake out of the silos and into the next part of the process. The optimum dry solids level for the next part of the process is between 14 and 16%. Therefore, at this point, we may add some final effluent to achieve the right consistency. The thermal hydrolysis plant uses steam and recycled energy from the CHP engines to rupture sludge cells. This ensures maximum biological availability for the next part of the process, which is anaerobic digestion. A series of large boilers produce the steam to feed our THP plant, which in turn heats the sludge within it. Using thermal hydrolysis to pre-treat the material before the next part of the process, which is anaerobic digestion, results in a much swifter and more complete digestion process. It also guarantees better destruction of solids. The next part of the process is anaerobic digestion. Our bespoke digestion tanks are sized based on the specific capacity requirements of each project. Within these tanks, we cultivate a colony of microorganisms that physically digest the organic matter. This process is very efficient at breaking down and therefore reducing the volume of solids, and also dramatically reduces the odour signature of the final product. As part of this process, large quantities of biogas rich in biomethane are produced and captured in gas storage vessels. This biogas can be used in two different ways. It can either be combusted in CHP engines to produce renewable electricity and heat, the electricity either being supplied to grid or used directly at the sewage plant, and the heat being reused upstream in the process. Or the gas could be directly injected into the national grid. In this case, the gas would need to be cleaned to remove carbon dioxide and the resultant biomethane efficiently prepared prior to grid injection. Direct injection of biomethane into the national grid represents a highly efficient use of biogas and is often reinforced by government subsidised payment mechanisms. Now that we have dealt with the gas that we've collected, we now have to deal with the remaining digested sludge. Due to the effective solids destruction within the AD process, we've reduced the dry solids content from 14% to approximately 6%. In order to effectively transport this material to its final market, we need a thicker and drier product. So a further dewatering process is undertaken to increase the dry solids to between 25 and 45%. This is achieved by polymer dosing and either a centrifuge or a hydraulic filter press. Once this has been completed, our finished product, known as biosolids, is stored in a final silo before being loaded into outbound transport. Our biosolid product is a high-quality, nutrient-rich organic fertiliser. It's highly valued by farmers when spread to agricultural land. Indeed, since we started sewage sludge operations, Agrivert have spread some 300,000 hectares of agricultural land with this product. In a strictly controlled and compliant operation, Agrivert's biosolids achieve maximum benefit for minimum cost, supporting a circular economy for the planet's depleting phosphate reserves and reversing long-term depletion of organic matter in arable soils. In markets where a strong agricultural demand does not exist, energy recovery represents the best outlet for biosolids. Using proven fluidised bed combustion plants, the dewatered biosolids are further dried and then combusted. The residual ash from such plants can be further processed to recover phosphate, enabling maximum utilisation of this bioresource. Agrivert are committed to operating in a responsible, compliant and transparent manner at all of our sites. Our sludge processing and recycling facilities are BAS compliant and HACCP approved. This means our operations are run in line with all relevant industry codes of practice, and the products we produce are recognised as high quality whilst meeting all required industry standards. Agrivert are very proud to build successful, efficient and best-in-class facilities. Agrivert, environmentally, technically and economically sustainable.